Let's examine calculating the alternating current draw for a large direct current motor. To estimate the alternating current draw, we can use a formula. The formula is alternating current equals the product of the direct current amps and the direct current voltage divided by the product of the alternating current voltage, 1.732, and the power factor. In the formula, alternating current is the alternating current being calculated. Direct current amps is the direct current in amps. Direct current voltage is the direct current voltage. Alternating current voltage is the alternating current voltage. The power factor is an estimated value typically between 0.8 and 0.9. Assuming a power factor of 0.85, the alternating current equals the product of 3055 amps and 230 volts, divided by the product of 480 volts, 1.732, and 0.85. This calculates to approximately 2129 amps. Now let's discuss disconnect sizing. The disconnects which must be rated for the maximum current that the motor can draw. In this case, the estimated maximum alternating current is 2129 amps. According to the National Electrical Code, the minimum ampacity of the disconnect must be 115% of the motor's full load current. Therefore, the disconnect should be rated for 115% times 2129 amps, which equals approximately 2433 amps. Based on the estimated alternating current draw and the National Electrical Code requirement, it is recommended to select a disconnect switch with an ampacity rating of 2500 amps. This will provide a sufficient margin of safety and ensure reliable operation of the motor.